Well, all right. Well, I guess it's just you today. It is Thanksgiving week. All right, so we'll start today's lecture with a continuation of the live session. But before, do you have any question about the homework assignment, the one that's due right before Thanksgiving? But no? Okay, all right, cool. All right, so we still have one more up. Well, I guess no, because it's due on Wednesday. So let me just kind of go back and talk about the assignment first a little bit, at least when it's due. And then we're going to proceed to talk about, how structures can be used for the live session program that we were talking about in the previous class. All right, so the homework assignment is Fibonacci. It is due on the 26th, and I believe it is due right before class. So that means, it is before 9 a.m. So right there. All right. So if anyone has any questions about that, please let me know before the due date. All right. So we're going to start with, go back and look at the live session of writing a program. And we're going to use exactly the same problem. Um, but this time we'll use structures. We'll use a student record structure, to deal with this. So we're going to go back and revisit, what we are given with. So first of all, we have an array of IDs where each element of the ID corresponds to the ID number of a student. We have an array called scores where each element is a real number going from 0 to 1. So 0 means 0%, 1 means 100%. Basically, it is the ratio of points earned for a student divided by the number of points that are available. The positioning of the elements correspond to the ID arrays, and neither is sorted. So that's the third point. And we want to maintain a separate array called thresholds, where each element specifies a threshold for a letter grade. So threshold 0, because all arrays are 0 oriented in C++, is the minimum score to earn a letter grade of D, and so on. And we finally have an integer called num students that indicates the number of students in the class. So there are a few things that are interesting. We'll read the whole problem first. So the first one is an array grades where each element of the array corresponds to the letter grade corresponding to a student of a matching element of the same index in the IDS array or IDs array. A value of 0 means a letter grade of F, and so on. So that means we have at least three things associated with each student. The first one is ID. The second one is the scores, which is just a number. And then the third one would be corresponding to the grade, which is 0 for an F, 1 for a C, B for a 2. No, I take it back. 0 for an F, 1 for a D, 2 for a C, 3 for a B, and 4 for an A. Okay. So what we'll do this time is we are going to write the program in a way so that it is making use of structures. So that's a different way of programming. You are instead of looking at tiny little pieces of information, you are trying to look at things um, from a logical unit perspective. Which in this case means, if I look at a student, what kind of information do I need to track with a particular student? So what we'll do is we are going to use a command line interface. So I would basically write the code using a command line interface. I'm going to use this one here, and we'll make it a little bit bigger, like so, and change the font a little bit, make it a little bit bigger too. So there we go. I think that's good enough. And then we are going to write the code up here, okay, in the CISP 300 folder. So the first thing we're going to do, this is going to be a evolving program. Let me start the folder first. Okay, so we'll make a folder. We'll call it, student rec. Okay, student record. And it's always a good idea when you move on to the next class to use a folder for every new homework assignment. So this way, all the files associated with the homework assignment are self-contained. And I'm going to show you how to use git, as a command line interface command. So you don't have to use GitHub, okay, because GitHub can be a little bit too much to set up and to utilize. If you're using a command line interface, you can always just use get, which is a very local resource, but it can still get a lot done just by using a local resource. So the first thing you do is you say get init, and what that's going to do is it will initialize the local folder so that we can use the get command later on in order to track different versions of the program. In this class, we're not going to use header files to track, things that might be shared across multiple source files. In later classes, you will have to handle that. Um, so we'll go ahead and start with the program. So we'll start with the program, and we'll just call it, student.c or CPP or C, which stands for C++. So now we'll go ahead and get started here. And the first thing I want to do is to define, the structure. In other words, we want to define a template where it specifies all the information that we want to track for a particular student. So now we can say struct student or student rec. Okay, doesn't matter which one we use. It's just a name. And we are going to start with the ID, which is an integer. Then we have a double, which is a corresponding to the score. And we also would want to use int again for the letter grade. And it's always helpful to write some comments. Okay, so ID is the student ID, and then the score would be from 0 to 1, and then the grade is going to be the GPA equivalent number, okay, but it is an integer, which means we cannot have 3.5. At ARC, it is not a problem because at ARC, the grade is only just the letter grade. We do not keep track of A minus, B plus, and so on. So it's not a problem here. All right, so that's the student structure. So one thing we want to do is to basically use functions to access various parts of the student of a student record or student structure. So it may seem like it is too much trouble, but it actually is useful. In this class, we are not going to use that particular approach just because we don't have a whole lot of time, okay? And we are not actually writing big programs. So we'll still be accessing the individual members directly instead of using methods or instead of using functions to access each individual member. And once again, just in terms of terminology, ID is a member of student, score is a member of student, and so is grade. So all the individual pieces inside the structure, each one is called a member. Okay. All right, so the next thing we're going to do, and the way we look at this is um, we might actually want to divide it into smaller structures. In other words, score and grade are related because they both deal with the academic record or academic performance of a student. So they can make we can make it into its own structure. So that makes it a nested structure, which is probably what we should do. Okay, so we're gonna make it happen here. So we'll go, this is a academic record. Okay, and inside we have score as a member, and then we also have grade as a member. So with these two grouped into AREC or academic record, now we can just make the next member of student to be a struct AREC, and then we can name it as performance or something like that. Um, I'm just trying to evaluate what is the best name for an academic record. So we'll just say this is ACAD, okay, which is the academic record. So this is the academic record, which only stores information about the grade and also the score, but it doesn't store the ID. All right, so now student is now a nested or hierarchical structure because it contains a substructure which ACAD is the name of the member. okay? And then the type of this member is a struct acad or a rec for academic record. Do we have any questions at this point? This is all good? All right. So now we go back to what we need to do, okay? And the output. So the first thing is, we want to calculate the grades of each student based on their scores. And I also need to have an array called thresholds, but that can be determined later. All right. So now we want to start a main, okay? And for the purposes of this demonstration, we are going to have an array of students or student records or student structures. And the way we do that is like this. You spell out the type of each element of the array, and then you name the array. I'm tempted to use class, but class is a reserved word, so it's not a good idea to use class in this case. So we are going to specify section, okay? So because each section is a class in terms of course offering, so we'll call this a section. And in the section, a section is an array of students, and that's why we use open and close brackets in this case to indicate that section is an array of student structures. And now we can initialize. So the initialization starts with an assignment operator, and you can do that too in your programs. And then inside the braces, each sub brace or each item inside the braces is representing a student structure. So a student structure would start with an ID. So I'm going to use a hypothetical ID of 1728445 as the ID. And then now for the second item, it has to be nested. So for the acad, which is by itself a struct, a rec, or a academic record, the first thing is going to be the score. So let's say it is the score is pretty good with this one. Let's say it's 0.92, and the grade is we don't know what it is yet. So we just put a 0 here, so that it can be calculated later. And now we make one more student. Okay, so we'll make this a 2031162, and this person has a score currently at 0.85. And once again, we don't know the grade because that's one of the things that we want to figure out. Um, I think 2 is going to be enough, because we just want to illustrate how to do this. Um, so let's go ahead and compile the program first. Okay, so we'll exit the editor, g++ dash g dash o, oops, dash o, student, and then student.cpp, everything compiled just fine. So at this point, if I want to, I can use a get to commit the file. So to do that, you have to add the file first. So every file has to be added to a repository exactly once in order for the repository to recognize that, oh, this is a file that I need to track, with all the different versions. So get add is going to add the student .cpp file into the repository, what we call repository. And this one is going to be local, which means you don't need network connection to do this. You don't need to have a GitHub account to do this. This is all stored locally. So once it is done, and I say, okay, the current version, I want to quote unquote check it in. Okay, to check it in means I want to store the current version of student.cpp into the repository so that later on, if I need to, I can come back to this version, either to compare the differences with the current file that I'm editing, or to compare between versions. So this is going to be handy. So now I can say get commit. Okay, so the command commit is to basically say, okay, whatever is in the file student.cpp right now, I need to take a snapshot of it. So add does not take a snapshot. Add is just saying, okay, this is one of the files that we need to track, but it has not really taken a snapshot yet. Every time you commit, we are taking a snapshot. Okay, so we're gonna say, get commit and then the file name, like so. and it will automatically open up an editor to let you enter what is the comment. Okay, what is special about this particular snapshot. So we can say initial snapshot. You got the structure defined. Okay, we have a sample class. Okay, sample class also defined like so. Exit the editor. So now we have one version checked in. So this can be really useful because later on we can compare against this version. So I'll give you an idea of how this can be useful. So let's just say that I I drink a couple of cans of beers and come back and did some nasty things and I just deleted one of the commas. Okay, so I go like okay, let's compile this program again. G++ dash G dash O student dot CPP, and obviously it is not going to compile anymore, right? Because I accidentally deleted a comma. So now the question is, oh man, this is terrible because none of the messages is telling me that I'm missing a comma, right? The first error message, says expected close brace before open brace token on line 14. It didn't say it's missing a comma. Okay, so that's why you might want to play with a program that is already working. Just remove certain things, add a few other things, and see how it is complaining about each error. Because the actual error message may not tell you what the problem is. So what am I going to do now? Well, as it turns out, with get, it is actually quite helpful because now you can say, get div student.cpp, and what it will do is it will give you a not so visual output, but it will still tell you that, in the old program, we had a comma here, okay, and in the new program, there's no comma. Okay, it shows you which line has been changed. So the line number that has been changed is going to be displayed here. So I believe it is line number 10, and I think that's what it is saying. It is line number 10. So we'll go back and take a look at whether it is really number 10. Okay, uh, colon 10. Nope, it is not. Okay, so this is actually line 13. So why is it not complaining about line 13? Hmm, that is interesting. But the point is, it does give you the difference, even though I'm still kind of at a loss here of whether of what is why it is not telling me it is on line 13. But it does graphically or not graphically, but it does show you which what the line looks like, so that is helpful. All right, so we go back here and then we go like, okay, fine, we're going to add this comma back. And you can also see that this comma is not needed because we only have two students. So the end of the second student, we don't really need a comma here, but it would take it anyway. Okay, it's not going to complain and go like, oh, but there's nothing after this comma. No, not a problem. It will still take it. All right, so now we can go ahead and practice a few things, okay? The first thing we're going to do is simply to implement the program or the code. Well, we need one more thing, okay? We need to give it an array of, the breakpoints of the scores, okay? So this is going to be the thresholds, okay? The thresholds array is an array of doubles where we have to indicate first where is the breakpoint between an F and a D. So let's just say this is a normal class, so it's zero point 0.6, and then we have zero point 0.7, zero point 0.8, and then finally zero point 0.9. So these are the thresholds of respectively um, between an F and a D, between a D and a C, between a C and a B, and then also, what qualifies to be an A, which is the zero point 0.9. All right. Now we're going to write a function. We're going to write a function here. But before we do that, we can still do the same thing as we did before. Okay, so we can now say, let's compile again. Okay, because we want to make sure the program does compile before we check it in. So this is student.cpp. Everything compiles, so it looks good. So that means, I might want to check this in again, okay? Which means I want to commit one more time. So we say get commit student.cpp. And once again, it puts me into an editor so I can add the comments of what is significant about this particular check-in. And I can say, added a threshold array. Okay, very minor changes, but it doesn't hurt. Okay, um, every time you check in a file, yes, it does use up a little bit more disk space, but not really significantly so. Okay, in terms of your file system, you're not going to notice anything every time you check in a file, especially for a program this small. It's not going to make any difference. Even if the program is really gigantic, what it stores is the differences between the versions. So that means if you have a 30,000 line source file and you only make changes to 3 lines and you check it in, it will only take the storage of those 3 lines. So it's not actually duplicating the entire file. It is only storing the differences between versions. So that means this is a really efficient way of keeping track of versions. Um, and I highly recommend doing this. Okay, just getting used to Get is going to be useful for many purposes. And then the last thing we want to do is to indicate the number of students in this particular class or in this section. So we're going to say n. We'll just initialize it to 2 because we have exactly 2 students in the array. This way, we have n already defined. We don't have to kind of reinvent n later on. Now, if you want to be super duper fancy, there's another way to do this. Okay. The reason why n being 2 or defining n to be 2 is not really the best approach is because what if I add like 2 more students in the section array? Then you have to go back and change n again. So it's not every time you encounter a mechanism like this where a single change triggers a whole bunch of other changes, you have to think about, do I have to do it this way? Are there other ways to do this? So in this particular case, as it turns out, there's another way to do it. So I'm going to introduce the other way. Okay, we'll comment out this line, which means, well, I'm not getting rid of it, but I want to kind of evaluate here what is the other way to do it. So the other way to do this is to look at the size of section. In other words, we're looking at the total number of bytes or the total number of quote unquote columns in our in this class that is taken up by the array called section. And then we're going to divide it by size of, in this case, struct student, because each item in the array is of the type of struct student. Size of struct student is um, the number of columns, in the terminology of this class, that each struct student needs. So if you take the total number of columns that are used by the array of struct student, and then you divide it by the number of columns per struct student, then you know that you have the number of students in this particular case. So yes, I am mixing the two concepts, the concept of an array and the concept of a structure. In this case, we have an array of structures. All right. So we don't know whether this is going to work or not. Okay, so we're going to say return 0, and then over here we need to give it a line to do something. Otherwise, it will optimize n out of existence if I remember correctly. But we'll see. So we go g plus plus dash g dash o student dot cpp, compiles again. But this time I want to run it. Okay, I want to run the program inside GDB because otherwise it doesn't print a single thing. And let's put a breakpoint, or list the program, put a breakpoint on line 22, run the program. And I'm not sure whether n, oh, okay, it does show n. So that means, this method works. Okay. So it is a fancy method, then comparing to, we always just, give n a particular integer. This time it figures out the integer using that particular construct. So now we want to check again, okay, by saying, okay, what if we have another student? So let's add another student here. Okay, so this student has been around for a little bit longer. So 1, 2, 8, 7, 5, 5, 6, 1, 2, 8, 6, 4, 5, 1. And the score is 0.78. We don't know what the grade is because that's to be computed. So we just added one more student here without changing the definition of n. Save the file, and then we compile again, and then we rerun the program in GDB. Then we're going to put a breakpoint at line 23 this time because we pushed everything down by one line when we added line 17. Run the program, print n, and you can see it automatically updates to 3. So this is a really, really useful technique when you are writing programs because you want the changes to propagate as much as possible by using the mechanism of a compiler instead of having to remember to do it yourself every single time because you are going to forget to do it at some point of time. Okay, so the self-consistency, if it can be enforced by the compiler, it's great. Okay, it is the preferred way of doing things. So now that we have understood a few new concepts, it's time to check it in. So we say get commit student.cpp, and then we say, okay, use size of to compute n. Okay, and that's it. Okay, save it. And now we have another check-in. So if you want to understand what commands you have regarding get, you can always just in Linux you can say man get, and it will show you all the options or many of the options of how to use get. And it is really long, okay? So it is actually helpful to go to the sub commands here, and you can see how we have already done. We have already explained add. We have not talked about most of the other ones, so let me go back again. Excuse me. There we go. We talk about commit, okay? So we can go, just talk about commit. We have describe, give an object a human readable name based on an available reference. We already tried div, okay, which is really useful. Um, and then there are many other ones, that we really do not need to get into right now. Some of these are really, really advanced, like merging two branches together. Those are much more the advanced topics. Push and pull are also very advanced because you need to set up a remote repository. Typically most people use GitHub for that purpose. So if you have a remote repository to share a project with somebody else, then you also need to understand how to do the push and also the pull. And then show is useful, status is useful. All right, and there are many tutorials online to show you how to use all the different commands, but right now we just stick with the really basic ones. So we go back to edit the source code again, and now we want to actually do something, okay? So I want to first make a function that can, mm, let's say, calculate the average, because that was one of the things that we want to do is to calculate the average. So now we need to specify the average calculation function. It returns a double because the average of score is going to be a double because every score is a double to begin with. And if you don't feel adventurous enough, we can just call the function average. So this time it still has to take in both parameters. The first parameter is a student structure array. Okay, and we'll call that section. Okay, so this does not really have anything to do with this section here. This section is a local variable of main. This section is a parameter of average. Okay, they just turn out to have the same name, but they do not overlap. Okay, because the scopes do not overlap. The scope of this particular section is within this curly brace and this curly brace over here. The scope of this particular section is within the curly brace block right after the what we call the prototype of a function. And then we also need n as the number of students in the section. So this is how we're going to do the average. So in the average, we will do the same thing that we did before. We have I as a local variable. I start with 0. As long as I is less than n, we are going to do the following. I need a double for the sum. And when everything is done, I'm going to return sum divided by I. So inside each iteration of this loop, we need to do two things. One is to add um, section I dot acad dot score to the sum. And then the second thing is simply to increment I, because we don't want to get stuck with one particular item in the array. So let me say semicolon here. So do we have any questions about average as a function? No questions? All right, very good. So I just wrote a function, and instead of continuing to write the next function and so on, I am going to test it first. Okay. So what I'll do is I am going to go here, and let's just use another local variable called class average or section average, so that the terminology is consistent. And then what we'll do is, this is the only thing we're going to do for now. Section average is going to store the return value of average, and I'm going to pass the section as the array of student structures, and also n, which is the number of students in the class or in that particular section, to average. And I can now delete the commented out line because that's not true anymore. All right, so I'm going to test this program first, but I'm not going to check it in first. Okay, I will test it. If it works, then I'll check it in. So let's go ahead and compile. Okay, gcc-g-o student.cpp. So if you are going to learn how to use the command line version of the compiler, G++ is the name of the compiler. -G is going to include what we call debug information in the executable. So this way GDB can be used to debug a program, because otherwise it doesn't know how to correspond back to the source code. -O specifies the following. Whatever is following -O is the name of the executable. So my convention is to use exactly the same name as the CPP file when it is a single file project, but it's not set in stone. Okay, you can use any name you want. And then finally, student.cpp is the name of the text file that contains the program itself. So give it a try. Okay, it compiles. Okay, doesn't mean that it is done correctly. So we're gonna have to test it. So once again, list the code, put a breakpoint on line 33, run it all the way to until we get to line 33, print out average. Okay, so in this case, average. Oh no, section average. Section average. It is 0.26. That doesn't seem right to me. It doesn't seem right. Okay, so we have a bug, which is great, okay? Because I like to debug, okay? I like to figure out how something is not working out right, just to find out why that is the case. I have a pretty good idea of why it is not working, okay? Because I missed one little thing, okay, inside the loop, but we'll go ahead and check it out, okay? So what we'll do this time is we're going to put a breakpoint in average. So in GDB, you can say B, which stands for break, or breakpoint. If you name a function, it will put the breakpoint right at the beginning of the function. So we'll do that, and then we're going to run the whole program again. But this time it will stop in average. So now we can single step, okay, while I is less than n, we do this. And here is the problem. The problem is with line 16 right now. Um, it is not adding the score to sum, it is overwriting sum with the score. So that means sum is only going to be storing the score of the last student in the section. Okay, so that's a theory. Okay, I know this is the bug, but I have a theory of why it is outputting the output. So what we want to do is to test that theory. So even though I have a theory about how to fix the bug, it is always good to verify that that really is the bug before we try to fix it. So what we'll do is we're going to delete the breakpoint. So we're going to delete breakpoint 2, and that's how we do it in on the command line. If you're using a GUI or graphical user interface IDE, which is integrated development environment, then you don't have to learn all the commands. You just have to kind of click on the line to toggle the breakpoint. So now what we want to do is to run the program again from the beginning. And right before it is going to exit, I want to print what is in section itself. So it tells me these are the sections. So if you divide 0.78 by 3, you get 0.26. That's how we got the 0.26. So we now have a verification of where the problem is coming from. So that means it is time to fix that problem. So now we go back to the editor, we go to the line that has a problem, which is this line here, and we just have to say, oh, we are not supposed to be overwriting sum with the current score. We're supposed to add the current score or the score of the current student structure to the sum. So that should fix the problem. And now we compile again, and then we debug again, and we put a breakpoint at exactly the same place as before, which is on line 33. Run the program until we get to line 33, and then this time when we print section average, now it prints, I think that's a correct number. Okay, it's the right order of magnitude. Okay, excellent. So that means I got one thing done. So what do we do? Commit. Okay, we check it into the repository, what we call the local repository. So we just run that commit again, okay, which is get commit, and then you spell out the name of the file, which is student.cpp. And this time we can say, implemented, okay, implemented and verified um, function average, okay. So it is good to include as much information as you want, as you need, I should say, just so that later on when you go back to an earlier version, you know what it is representing. Okay, all right. And it even tells you what the changes are. We have 12 lines inserted, 2 lines deleted compared to the previous version that we checked into Get. All right, so we got one thing done, and then we go back to the code. And the other thing we need to do is to convert um, a score to a letter grade. That's the next thing that we need to do. So we're going to implement the function, and then I'll show you guys how to debug it. So that one, I'm just going to say it is a void function, which means it does not return a particular value. And we'll just call the function score to grade. And interestingly, all we're going to do is to pass it a rec. Okay. So this is what we're going to do. And we also have to make sure that this is passed by reference because we are going to change one member of the structure so that we calculate the letter grade based on the score and then overwrite the grade member of the same structure. So that's what we're going to do. All right. So I hope you guys still remember how to do this. Um, I'm going to do it the clumsy way first, and then we'll do it the smart way. Okay. So the clumsy way is to say, okay, we need a new integer I, and then we just say that um, uh, while, and let me see if I still remember the condition. Okay. So we are staying in the loop as long as the score of the academic record is less than the threshold. So score to grade also need a thresholds array, which is an array of doubles. So these are the thresholds. It is an array of doubles. So we need that too. So we are now comparing against thresholds bracket I, and then we say if it is still less than, then we need to increment I. So I gets I plus 1, but we also have to double check that I is still within range. So that means we either hard code that the highest possible grade is 4, or we pass it as a parameter. So which way you want to do it kind of depends on the context. To be more flexible, it is better to just kind of pass it along. So I'm going to pass that number along. Okay. So now we have one more parameter here. It is an integer, which is the number of letters grade, or the number of letters, which stands for letter grades. So now we have to also make sure that I stays less than num letters. So we have to now say if I is less than hmm, num letters. Okay, I think that will work. I'm just checking the boundary conditions in my head, okay, but I think this is going to work. So this line on line 24 is really significant. The first condition, or the condition to the left-hand side of the logical AND, is basically it serves as both a condition to stay in the loop and also a condition to guard, it's also a guard condition of the right-hand side of the conjunction. So let me explain the two. The first one is what happens when I equals to num letters. That means we have compared against all the thresholds already, and the grade is as high as I can possibly get. Or I should say the grade, okay? So the grade is as high as it can get, is as it can get when I equals to the number of letter grades. So what if it is less than? Well, if it is less than, that means potentially the student can still get one more bump, or more bumps to the next grade. So to determine whether we can still bump the letter grade up is to rely on the right hand side of the conjunction. The right hand side of the conjunction says the score has to be less than. Ooh, okay, I just reversed the comparison because it should be greater than. Okay, because if it's less than, this has to be greater than. So that means we have not yet found the proper letter grade. So whether it is greater than or equal to, that depends on what the threshold, how the threshold is defined. In this case, it should be greater than or equal to, because if the score is greater than or equal to a particular threshold, then it should bump up to the next grade. And how the way we can understand this is what if somebody has exactly zero point 0.9 as a score? Okay, so now you ask if a CAT score is zero point 0.9 and thresholds which can only go as high as 3, which is also a zero point 0.9, the question is should we change the letter grade, which is represented by I, by 1? The answer is yes, okay, because a score of zero point 0.9 is corresponding to a letter grade of 4, so we should still get it one, we should bump it up by one more, okay? So I'm debugging the program as we talk about it. You guys might need to run it before you can actually determine whether the program is doing what it is supposed to be doing. So after this is all done, then we can now say acad dot grade, which is an integer corresponding to the actual letter grade of A, B, C, D, F, is going to be I. So this is one way to do it. It is the slightly clumsier way to do it, but it is kind of clear, that I is really just the quote unquote experimental letter grade, and we just want to do all the calculations correctly, and then we assign I back to a cat.grade. So what do we do now? We're going to test it. Okay, we're going to test this. And the way we're going to test it is only to use one of the student records to test it. Using um, it is probably best to have one more here, which is another boundary condition. So we're going to make this one a 5, okay? And we'll just change the ID to 3 here. So now we have someone who should be getting a letter grade of F, and also someone who should be getting a letter grade of A. And if you want to really check the boundary conditions, then this should be a 9.90, which is exactly right at the threshold. Because if it works right at the threshold, then it should be working above the threshold. All right. So what we'll do is we are going to test it separately. So we are going to call score to grade in two different calls. So if you want to use the 0.90 and 0 here, that is corresponding to element 0 of section. So we are looking at section 0, but it is not the entire record either. We only want to pass along the ACAD member of that entire record. So you have to specify the member of ACAD and not the entire element 0 of section. And now we also have to indicate that there are exactly, we have to pass on thresholds as the array of actual thresholds. And we also have to now specify how many thresholds do we have, or what is the um, highest letter grade that people can get, which is supposed to be a 4. But remember what we said. We don't like to use 4 because if we use 4 here, that means if later on we have a letter grade system that has more than just 0 to 4, then we have to update everything. So now how do we do this? How do we say, okay, the number of thresholds or number of letters in the letter grade system is going to be calculated based on the number of elements of thresholds. It'll be the same thing. Okay, we say number of thresholds is going to be the size of thresholds divided by the size of whatever each element of the threshold is. So in this case, it is a double. Okay, so there we go. So this way, we don't need to do the calculation by hand. We can now just automatically calculate the number of thresholds based on the size of the thresholds array. All right, so we have done quite a few lines of programming. It is time to test it. So we exit the editor. And once again, if you want to compare the file as it is right now, compared to the last time you check in with get, you can just say diff. So get diff student.cpp will show you all the differences. It is color coded, which is kind of cool. It shows you, the ones that are inserted as green, deleted ones are in red, and so on. So this is a semi kind of graphical output of what is being changed with this particular program. Do we have any questions about this part? Nope. Okay. All right. So we're gonna compile. Okay, and then debug. And this time we'll put a breakpoint on line 44 again, right after score to grade, like so. Run the program, it's all done. You can print out the entire section. Okay, so you can now say print section, and it will show you every single record. So now it is saying that the point 0.9 score did in fact get a grade of 4 or letter grade of 4, and that is correct. Okay. So that means, okay, so we know the program is kind of working. So now it is time to check it again, but this time we want to look at um, the structure that is supposed to get an F. So if this is bracket 0 or element 0, this is element 1, element 2, this is element 3. So we're going to repeat this whole thing. And now we specify, okay, let's go check out element 3, which is the last record of that entire array, and see whether it works or not. So now we, once again, compile, debug, uh, list the program, put a breakpoint on line 45, run the code. This time we want to print the entire section again. And only the first and the last record should have a score already computed. And we can see that, ew, that is not good. It is also a 4 over here. Okay, so that means the logic of that loop is not exiting early enough. Okay, so it kept itself in the loop when it's not supposed to be in the loop. So it's time to debug the program. Okay, so we go back to the loop here, not this one, but this one over here. It did not exit when it is supposed to exit. So there's only one culprit. The left-hand side of the conjunction is not a problem. Okay, it is the way it's supposed to be because in order to stay in the loop, I need to make sure that I is a valid index. So the problem has to be the other one. Okay, the score of the academic record is if it is greater than or equal to the threshold I, we stay in the loop. Okay, so with a 0.58 as the score, and we're comparing to thresholds 0, 1, 2, it is not greater than or equal to, so it should have exited the first time. Oh, I remember why it is a problem. This is a classic problem, and the problem could have been detected a little bit earlier. Okay, let me show you the tool. If you use a G++ again, but this time you add warn all, okay, dash WALL, wall. So the first uppercase letter W means we are specifying warnings, and then we're specifying all warnings. Okay, so in other words, nag me. Okay, nag me as much as possible. Okay, if it seems like I did something wrong, tell me about it. So it will report not only errors, but it will also give me all the possible warnings. The rest can still be the same, dash G dash O student dot CPP. And you can now see that, okay, there are two warnings. One is section average was set but not used. Okay, when you see the phrase set but not used, it means a variable was written to, but it doesn't seem like anyone cares about it. Okay, so yes, it is a warning that you might have a variable that was intended to do something and somehow you forgot to use it. But it is not the first problem, the warning. The second warning is the problem. The second warning, if you look at the warning here, it says I is used uninitialized. Now, that is a big no-no, okay? This is the reason why in a trace, every local variable that is not initialized start with a question mark to emphasize that we have no idea what the value is. We know there's a value, we just don't know what it is. So that is the problem, okay? And so we're gonna go fix the problem because in here, not this one, but here, I should be initialized to 0 first. Okay, because otherwise it is an uninitialized local variable, which means it could have started with 25 for all we know, okay, which is not even a valid grade point, okay. So now we think we have fixed the problem, okay, so we're going to go back and run the G++ command. It's still complaining about the first one, which is section average not being used. Once it is set, that's okay, okay, we're not too concerned about that. Um, so now we can go to GDB, okay, GDB student, put a breakpoint again on line 46, run the code, and then we print the entire array called section. So this time we can see the score of the first student, the one with a score of 0.90, the grade is a 4, that's correct. And then the last student, which has a score of 0.58, has a grade of 0. That is also correct. Okay, so now we go like, okay, this is good. We have just debugged score to grade as a function. So every time you make progress that is significant, it's time to check it into get. So we're going to use get commit again. Student.cpp. And this time we kind of write it very carefully, and we say implemented and verified the function called score to grade. Okay, save the code, save the text file, exit. So now we have another revision saved in the repository. Do we have any questions at this point? No questions? Okay. Hmm? No, sorry. Oh, you have a question about the homework? Well, we can talk about the homework. Hmm. It's n minus 1. Yep. So the n dash 1 is n minus 1. Subtraction of 1. All right. What about this program? I'll be okay with this program? All right. So now I can say, okay, if I can convert the score to a grade correctly for individual uh, student structures, I can now just use a loop to do it for the whole class. Okay, so that's what we'll do. Okay, that's what we're going to do next is to go back to this program, write another function to do this. Okay, so if it is possible, it is good to not to put all the logic in main, and instead you break it up into smaller pieces like this. So we can now say score section. So score section is going to be based on score to grade in the sense that you have to give it um, an array of structures, but this time it will be an array of student structures, not academic record structures. So now we say, okay, there's a whole bunch of student record here, and once again, we'll call it a section, and we are going to, oh, okay. In this case, because it is an array, it is automatically passed by reference, so there's no need to write ampersand in this case. We still have to let the function know where the thresholds are. So we still have to provide thresholds or thresholds as an array. And we still need to supply what is the total number of letter grades. But we have one more parameter. We need to also indicate the total number of students in the section. So now we have another integer parameter here. We can just keep n here. Okay, so that's fine. All right, so now what do we do? We just say, okay, for each student in the section, we are going to call score to grade for the academic record of that particular student, and that's all this function needs to do. Okay, so now we just have to say, okay, int I, okay, I is once again a local variable for going through an array. I equals to 0. This time I remember, and then we have a while, blah, blah, okay? And this is also one thing that I usually do, which is um, putting in things that I tend to forget first, okay, which is forgetting to increment the array. So this time I need I to be less than n because n is representing the number of students in the section. So as long as I is less than it, I is still a valid index. And then the second thing I also need to do, well, actually there's no second thing. This is the only condition that I need. So inside the body of the loop, I just have to call score to grade. Now, this is the interesting part. Okay, so the interesting part is I need something from section I because I is controlling which element of section we are accessing, and I is being changed per each for each iteration. It goes from 0, 1, 2, and so on. And but I don't need the entire record. So let me show you what error message is going to happen here. And then we need to pass thresholds just the way it is. We need to pass num letters just the way it is, like so. All right. So even though at this point main is not calling score section, I can still compile the program and see the problem. Okay, so this is one unique thing about a compiled programming language, or what we call a strongly typed programming language, like C++, like Java. Okay, those two are the strongly typed programming languages. Is you can always compile and see what problems may be around. With scripting languages like JavaScript, with the exception of TypeScript, but with regular JavaScript and Python, you have to run the code to step onto a problem in order for the problem to be complained. But in this case, I don't need to do that. Let me illustrate what I mean by that. So we go back and compile the program again, and you can see that there's a warning, okay, that is not an issue, but the problem is we have an error. The error is on line 35. It says invalid initialization of reference type struct arec ampersand from an expression that is of the type student. It spells out exactly what the problem is. Okay, so that means oh, okay, if the problem is spelled out explicitly, it is easy to fix. It is on line 35. So on line 35, instead of passing a struct student, I should be passing along a struct arec, and the arec is the member of a CAD inside a student record. So now we are specifying a member of a student structure that is of the type of a rec. So now it should compile, okay? Even though main's not calling it, the compiling is fine. It is the same warning message that we have seen before. So the program is okay at this point, okay? In terms of making sure all the types are, working out or consistent, everything is good. So that means I can now remove these two lines, and instead we can just go ahead and call that function that we wrote earlier, which is, I cannot remember the name anymore, score section. Okay, there we go. So we have to call score section, and there are four pieces of information that it needs. It needs to know about the section, which is an array of student structures. It needs to know how many there are, which is our local variable n. It needs to know the array of the thresholds, okay, where is the breakpoint between the A and B, B and C, C and D, and then D and F. So that would be our array called thresholds. And last, it needs to know how many thresholds there are, which in this case is num thresholds. Like so, and save the code and try to compile again. Okay, so hopefully it only complains about the same line that we had before, which is good. Okay, now we can run the code. GDB student, put a breakpoint at the very end, run the code, print section. And this time we have to be more careful because this time we look at the first student structure. It has a score of zero point 0.9 and it has basically a GPA or the grade point of 4. That works. The second one has a score of 0.85. It has a grade of 3. That works. The third one has a score of 0.78 and it has a score of 2 or a grade of 2. Is that correct? Yeah, I think so. Okay, because and then the last one has a score of 0.58 and it has a grade point of 0, and that is correct as well. So we have completed all the points that I can remember of this entire thing. Okay, yep, I did everything. Oh, we can also implement standard deviation. So this is a real number called standard deviation and also an array of ranking. Okay, so one thing at a time. Okay, we still have enough time in today's lecture, so we can now try to calculate the standard deviation. So the standard deviation is calculated by um, adding up the, okay, we can we can look it up, okay, but I can derive it again. So it is the sum of all the scores divided by the total number that would be the mean, and I think it has to do with the square of each item. I'm just trying to figure out whether we have to do the average first, okay, or not. Because if we can do the average, if we have to do the average first, that means there's an ordering between the two. Well, that's the cleanest way to do it. So let's go ahead and do that. Or we can go for the last one, which is structurally it is a little bit more interesting because we want a ranking. Okay, in other words, who is who's ranked number one, who's ranked number two, who's ranked number three, and so on. We want to find out the ranking. So this one is it requires one more item for each student structure. So we'll do that first. Go back to the command line here, and then we go to, oops, there we go, quit, go back to this part. And this time, the ranking is on a per student basis. It is not an academic record. So we're going to have to put the ranking here. Okay, so we'll say ranking. All right. So ranking is a little bit interesting because you are going to have to find the first place first. And then after that, you have to find the second place, the third place, and in this case, the fourth place in the class. So the logic to do that is a little bit, I would say it's a little bit harder, for this class because you have to sort it. Eventually, basically what you need to do is to sort the array first in order to figure out, who has the highest score and then who has the next highest score and so on. So we're gonna need to sort. But the restriction of the description here is we are not supposed to change um, the original arrays, okay, because it says we can add an array called ranking, but we are not going to change the ranking or the elements in the IDs array. So we have to maintain the array as it is, but somehow we have to figure out the sorted order of all the student structures. So now the question is, how are we going to do that? So what we need to do is to introduce another array which is based on the total number of students in a section. So we're going to have to specify another array here. And this is going to be ranking as an array. And then the number of elements in here will be the same as the number of elements in section. So it's going to be n over here. Now, I cannot remember whether I can do something like this because n is a local variable, and then we are relying on the value of n in order to determine the size of ranking. So I cannot remember whether this is permissible in C++, so we're going to have to test it first. And it says, cannot convert brace closed initiator list to integer in initialization, close brace on line 47. All right, so let's check out what is on line 47. Uh-huh. Yep, so we cannot do this. Hmm. That means we have a little bit of an issue here because it's hard for me to make, I mean, I know how to get around the problem, but I don't want to complicate the problem, the question to um, deal with that. So for now, we can change this to a constant of 4 so that I don't have to explain the approach. Oh, it still has the same problem. Cannot convert brace and close to that. Okay, unused variable, that is not a problem. Huh, okay. It is complaining about line 47, and that's after we introduce line 54, 52. All right, so let's just say that I am at a loss here. This is why we use get, okay? Because I can now compare this program versus the last working version. So we can now say get diff student.cpp, and now it shows me the differences. Oh, I forgot to check in when I got the whole thing working in the first place. Oh, okay. I just did something that I'm not supposed to. Okay. All right, so we're gonna have to go backtrack a little bit, get rid of ranking because that was the last change. And then we give it one more try. Nope, nope, not this. Compile. There we go. And it is still complaining. Hmm. cannot convert brace and closed initiate the list to int. So somehow it wants to convert it to an integer. Okay, line 47. So it wants to convert section to an integer. So maybe it has to do with score section. Score section is using section as an array. That is correct. Okay, let's rule out this call. We got it working before. So what did I do to make this program stop working? Okay, we'll comment on line 54. It's still complaining, the same problem. So we know the problem is not because of the call. So it has to be something earlier. Okay, I'm checking the braces, make sure they all match up. All right, brace enclosed initializer list to int. In initialization, line 47, which is, I know where that is. Brace enclosed initiator. Oh, I know, because we add one more thing here. So it's okay. So that's the problem because we added ranking as a member. So now everything that we do put into the initializer, it also is supposed to be adding one more thing here, 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 and here. Yep, that's what it's complaining. Okay, so just to reverse the program back to what it was before, and I forgot to check it in, that was my fault. So we go back and reverse that. Okay, we basically pretend that we don't have to do anything about ranking, and then make sure that the program still compiled this time. This time it did compile. So it's time to check it in because otherwise I forget to do it. So now we say get commit student.cpp got score section working. Save the file. So now I have a snapshot of that version. So I believe that we don't have enough time in 7 minutes to finish up, the sorting portion, because if I want to explain, how sorting works, that's going to take a little bit longer. So I would say this is the end of the lecture itself. Do we have any questions? No questions? Any questions about the homework that's due on Wednesday? Hmm? Say again? Still working on it? Okay. All right. Cool, cool. All right. Well, if there are no specific questions, I will go ahead and stop the recorder, get the lecture uploaded. But the value of today's lecture is a little bit more pragmatic. I'm no longer just explaining concepts. I'm actually applying the concepts in the implementation of a program today. All right, so let me close the recorder.